Less than 1% of the global fleet is electric right now. We better figure out electric cars and sustainable energy, or civilization is going to crumble.
We are starting our pilot full-scale recycling production at Gigafactory Reno next quarter.
As we get more electric vehicles on the road, people are starting to question the environmental impacts of batteries. So in this video, we'll look at how Tesla is approaching battery recycling and mining the raw materials. But first, let's get plugged in. Hello and welcome to EV, source for all things EVs and technology. Before we begin with today's video, I wanted to take a moment to welcome our newest Patreon producer, Carlo Herman. Carlo, thank you for your support. You are amazing. Also, a special thanks to all of our Patreon producers who help to make videos like this one possible. And an extra special thanks to our power producer, Inku Kang. Thanks to all of you for your continued support. And now let's jump right in. When it comes to recycling old batteries, especially now that we are heading toward a future where vehicles will be fully electric, questions regarding battery recycling are becoming more important than ever before. Along with this comes concerns about mining the raw materials for batteries and the environmental impacts of such activities. If you watched the Battery Day presentation, you'd remember Elon Musk talking about Tesla mining lithium in Nevada.
So it's important to note that there is a massive amount of lithium on Earth. So lithium is not like oil. There's a massive amount of it pretty much everywhere. We actually got rights to a lithium clay deposit in Nevada.
Over 10,000 acres.
And then the nature of the mining is actually, I think, also very environmentally sensitive in that we sort of take a chunk of dirt out of the ground, or remove the lithium, and then put the chunk of dirt back where it was. So it will look pretty much the same as before.
And there really is enough lithium in Nevada alone to electrify the entire US fleet.
Though this sounds promising, many companies mining lithium in the past haven't done a great job at minimizing the environmental impacts. There have been several cases of chemical leaks that made it to rivers and lakes and killing local wildlife. But knowing Tesla and the way they operate, I have enough trust and faith in the company that they will do the right thing and minimize the environmental impacts as much as possible. Mining for nickel, however, is a different story. This is why Elon Musk urged companies to mine more nickel in an environmentally friendly way.
Tesla will give you a giant contract for a long period of time if you mine nickel efficiently and in an environmentally sensitive way.
We know Tesla will mine lithium, but will they also mine nickel? I guess only time will tell. But as for cobalt, well, Tesla is slowly moving away from cobalt. They currently have about 5% cobalt in their batteries, but the company has a plan to move away from cobalt completely, so I wouldn't be too concerned about it. So going back to battery recycling, companies are motivated to recycle old batteries for their raw materials instead of getting them through mining. They get a better yield for less cost through recycling than mining.
When we get to this steady state 20 terawatt hours per year of production, we will transfer the entire non-renewable fleet of both power plants and industry heating and vehicles to electric. And at that point, we have an awesome resource in those batteries to recycle to make new batteries. So we don't need to do any more mining at that point. And you can see why. Yeah. The difference in the value of the material coming back from the vehicle versus the ground, you'd always go to the vehicle.
So how does battery recycling work? Well, I'm not an expert on recycling batteries, though I do understand the basics of it, but I'll let Sandy Munro do the explaining.
There are many companies working on that currently. Most of them are going to use a chilling process. So you take the structural adhesive and the battery pack and whatnot, and you drop it into liquid nitrogen, you crush it, you make sure that there's an inert gas over the top of everything so that nothing can catch on fire. You grind it all up into small pieces, and then it goes into weirs and several different other different batches for separating the elements, and ultimately you wind up with lithium here, nickel there, and all the other, and cobalt in another one. So it's not the easiest thing in the world, but it's a whole lot easier and better than digging up thousands of square miles to try and extract the ingredients needed for making lithium-ion batteries.
And we recycle 100% of our vehicle batteries today. And actually, we are starting our pilot full-scale recycling production at Gigafactory Reno next quarter. to continue to develop this process as our recycling returns grow.
Yeah, I mean, to date it's been done by third parties, but we think we can recycle the batteries more effectively, especially since we know our batteries, we're making the same battery as the thing we're recycling. So whereas like third-party recyclers have to consider batteries of all kinds.
But then of course this raises other questions, such as how long would we have to mine the raw materials for batteries? Though there's not a straight answer to that because there are so many variables, but we can guess by running through the numbers. Roughly 100 million cars are made every year, and it is estimated that there could be over 2 billion cars on the road by 2035. Tesla is aiming to produce roughly 3 terawatt-hours of batteries annually by 2030, though I personally believe Tesla will reach this goal much sooner than that. Now, if we assume that an average electric car battery pack size is 75 kilowatt-hours, with 3 terawatt-hours of annual production, Tesla alone could make approximately 40 million vehicles a year. That's assuming all the batteries go into vehicles, which they don't, since Tesla has other energy products such as the grid energy storage systems and power walls for home energy storage. So let's say only half of the batteries go into vehicles, which means Tesla would produce about 20 million vehicles per year. This means only half of the 3 terawatt-hours goes into vehicles, which is probably not the case, but let's just assume so for this example. That's still just 1/5 of the global vehicle production. Globally, we would need closer to 10 terawatt-hours of annual production to have all 100 million vehicles produced every year to go electric.
You basically need on the order of roughly 10 terawatt-hours a year of battery production to transition the global fleet of vehicles to electric.
But you have to remember, not all the batteries would go into electric vehicles. The energy sector is still pretty much untouched, but once Tesla really puts some real attention to grid energy storage and renewable energy, a lot of the batteries would go into this sector, and at that point, Tesla may not be the only one converting the grid to support energy storage. So to do all of this, according to Elon, roughly 20 terawatt-hours of sustained annual production is required.
And then on the grid side, we have a similar mountain to climb, 1,600 times growth from today's grid batteries to go 100% renewable on the grid, and to take all of the existing heating fossil fuel uses in homes and businesses 100% electric.
Yeah, and this number, I think, might grow even more, as the world economy matures and as countries with high populations industrialize, we could see this number be even more. But let's say it's like roughly 20 to 25 terawatt-hours per year, sustained for 15 to 25 years to transition the world to renewable.
Now that's a lot of batteries pumped out every year. Remember when I said it's estimated that there will be about 2 billion vehicles on the road by 2035? Well, at this rate, it would take roughly 20 years before about 2 billion vehicles are electric. That brings us closer to 2050, assuming we reach a 20 terawatt-hour production capacity in 2030. But hey, knowing Elon, things could accelerate a lot faster in the coming years, and all the vehicles could be converted to electric much sooner than that. But let me know when you think all or most of the vehicles will become electric. Batteries are already coming in for recycling from old electric vehicles, and these can either be recycled for raw materials or used for energy storage. Once there's a substantial amount of batteries coming in for recycling or reuse in other applications, less raw materials would be mined for new batteries. And once all vehicles have been converted to electric and the grid system goes from where it is today to fully renewable sources where energy is collected from the sun and the wind and stored in batteries for later use, mining for raw materials for batteries won't be necessary. Old batteries from vehicles can still be used in energy storage systems even when the battery capacity goes below 80%, until they further degrade, at which point they will be fully recycled and broken down to raw materials to make more batteries. I think the next 5 years are going to be crucial for electric vehicles and battery production as the demand for affordable electric vehicles increases. And as you probably already know, Elon did finally confirm a $25,000 Tesla that would be equipped with self-driving hardware just like any other Tesla today.
About 3 years from now, we're confident we can make a very compelling $25,000 electric vehicle that's also fully autonomous.
When Tesla finally releases this truly affordable vehicle, that will be the final blow to ICE vehicles. From there, it won't even make sense to buy anything other than electric vehicles. Heck, to me, it already doesn't make sense to buy anything other than electric vehicles. But those of you who are still on the fence about EVs, give it another few years and you'll come around. In the end, you won't really have much of a choice once all vehicles manufactured are electric, unless you want to be the only one driving an old gas guzzler. Who knows, there might even be new laws by then that prevent non-electric vehicles to be driven on public roads. But hey, we're still in the very early phases of electrification of vehicles, and there's a lot of work ahead before any of this will happen. But it's great to stay ahead and know the direction we're heading toward and the changes that are bound to come sooner than later. What would it take for you to transition to an electric vehicle? Honestly, let me know in the comments, because I'm really interested to know what motivates you to switch or not to switch to an electric vehicle. And if you made it this far into the video, you are awesome. If you own a Tesla, get 10% off on your purchase when ordering accessories for your vehicle from Abstract Ocean by using the code EVSource or the link in the description. Also, check out our merch store for shirts like this one. There are t-shirts, hoodies, phone cases, bags, and a lot more, so check out the store from the link in the description. And if you want to show more love and support to the channel and get exclusive access to Q&As, early access to videos, and get a look behind the scenes, consider becoming a patron and help the channel grow to make more videos like this one. But if any of these forms of support are beyond your reach at the moment, just remember the most important way for you to support is by watching and liking these videos. And before you go, make sure to subscribe and turn on the notification bell so you don't miss videos like this one. Thank you for watching. My name is Harry and this is EVSource. Keep charging ahead and I'll see you in the next one. Stay safe and take care.